I'm on. Okay, so the very first one, the integral from 0 to 3 of x dx. So notice x dx. This is going to be a power rule. What's the exponent? 1. So we'll first say 1 over 1 plus 1, x to the 1 plus 1. So that's the antiderivative. Is that okay? And remember, this is between 0 and 3. So the only thing that's new is the vertical line and no more plus c. What is the cleaned up antiderivative? So 1/2 x squared, again between 0 and 3. So then all we do is we stick in 3, the top bound. Subtract, we stick in 0, the lower bound. Well, notice 1/2 times 0 squared is just 0. So what is 1/2 times 3 squared? 9/2. Or 4.5, either one's okay. Hooray! So looking at our picture, what we just found is we found the area under the curve from 0 to, I think that's 3. Mine's a little blurry. This area right here is 9/2. That's what we just did. Notice if we were to draw the picture, we wouldn't need calculus to figure out the area, because notice the picture is a right triangle. And the area of a triangle is 1/2 base times the height. Well, notice the base is 3. The height would also be 3. So what's 1/2 times 3 times 3? 4.5. So we got the same answer. However, if you notice in part B, we don't have a triangle anymore. We don't have a curve. We have a curve. So simple geometry won't help us anymore. So that's where calculus would need to kick in. All right, part B. Let's rewrite this down. So notice again, this is another power rule. Thinking about the power rule, how would you rewrite 1? X to the 0. So if you would, I'm not going to write the intermediate step anymore. What is the antiderivative of x squared? One-third x to the third. And what's the antiderivative of 1? X. So that's what I want you to be able to do by now. 1/3 x to the third plus x is the antiderivative of x squared plus 1. What does that vertical bar say to do? Very good. Plug in 5 minus plug in 2. What do I need to put around when I plug in 2? Parentheses. Actually, I don't even think it's a fraction. What'd you get? What'd you get? 42! The answer to life, the universe, and everything. If you don't know the reference, shame. All right. So what we just found was, here's 2. Here's 5. So the area under the curve from 2 to 2. From 2 to 5 is 42. Then notice the closest geometric shape we could have used was a trapezoid. but that would be an over approximation for this graph.